Hello there, and welcome back to the Developer's Guide to Windows 10. I'm Andy Wigley.
Hi, and I'm Shen Chauhan.
Right, now, if you're watching the live event, the scheduled session now was data binding. We're actually going to push that off until first thing tomorrow morning. So, real apologies if you were specifically waiting up for that one. For our compatriots in the UK, you're probably sitting there with a cup of cocoa and thinking you were just, oh, I'll go to bed soon, but I really want to watch this session. But we're going to do App Lifecycle instead, which is just as exciting.
It's worth staying up for.
It totally is, totally is. So we did a session this morning. We were talking about page navigation.
Yeah.
And that was a lot of interesting stuff about the back button. Who thought that could be so interesting? Yeah. But actually tied in with that, the whole thing about the page history and the navigation does tie in very much to App Lifecycle and preserving the user experience, as you'll see in this one. So we're going to talk about the life cycle, how you handle suspend and termination, and then there's some new features if you are an existing 8.1 app developer, which was some ways of having extended execution to run continuously in the background, that kind of thing, in specific circumstances. So we're going to look at that as well. So, right, first of all, what is the app life cycle? Why do we even have one? Why do we have a life cycle? It's like...
Why do we have a life cycle?
Yeah, well, and it's about mobile, isn't it? Everything is mobile these days.
Yes.
And the old days when computers were big hulking things sat on a desk and permanently connected to networks and permanently connected to power, those days are gone. So, you know, batteries on these kind of things are getting pretty impressive.
True.
Yeah, but obviously the most frustrating thing for a phone user is not getting through the day with the battery. So if you have that battery going flat, this is bad news. So how do we give users of mobile devices a great user experience, but also maintain that precious resource? Well, basically what we do with mobile computers, and it's come from smartphone, but actually extending it, the same rules apply to portable handheld computers, bigger ones like tablets, like laptops.
Anything you can pretty much carry around that doesn't have a power cable that's permanently connected, really.
Yeah, well, obviously these kind of machines, because of their physical size, can have a fairly big battery in them. So, but then again, they tend to run, do different jobs and this sort of thing. And
you know,
these are typically running a combination of classical Windows apps, which don't know about the fact that they're meant to sleep and stop using resources every so often. They were built in an age when, you know, power and network, what the hell, what the heck, we have loads of that. Yeah. But coming from a smartphone and actually moving across also into to bigger machines is this idea that, well, okay, let's be power efficient about this. Let's only burn battery, let's only use the CPU when we really need to. So when an app isn't actually visible, when the user isn't interacting with it, well, let's suspend it. So this is what the app lifecycle is. Come from a smartphone, it's extending across all modern apps. And the idea that on a mobile device, Windows 10 mobile, on the phone and small tablets, you only have one app in the foreground at any one time. And that is the one that is active. All the others are suspended.
Pushed away.
On desktop, well, we can have more modern apps can be visible at any one time, and obviously, if they're visible, then they are alive. But if you minimise them, for example, then they will get suspended just the same way on desktop. So if they're not actively being used, then they get suspended. And in certain circumstances, maybe the system is getting memory stressed and this sort of thing, then the OS will terminate.
They'll just terminate your app, and you don't really. No, it's not like an easy way of just saying, oh yeah, I know I'm going to get terminated at this particular point. You're just sort of given a very quick notification. It's like,
no, that's right.
Later.
Yeah, you're out of here.
Yeah.
No notification. You're just gone. Now, this sounds like a recipe for making it difficult to create a great user experience, but actually the OS has many mechanisms for an app to appear alive, and actually you as a mobile app developer, kind of have to buy into this idea of maintaining the illusion to the user that the app's never been away, even though it's been suspended or actually might even have been terminated. You can actually bring it back and put the user back exactly where they were, put them right back in the middle of the work they were doing, and they don't need to know what's been going on in the meantime. That's your goal.
In some sense, just making sure that they feel like they never left the app.
No, that's really the goal. And we also have mechanisms anyway, so regardless of that, and we're talking specifically about the foreground app experience there, but also we've got mechanisms for executing code in the background tasks. We've got a separate session on that we'll talk about another time. So yeah, this is kind of a diagram. So the 3 states you really need to worry about for a foreground app is it could be, well, it starts, one that's not shown is not running.
Not running. Yeah.
Which isn't really a
it's not a state, you don't do anything at that point,
let's say
right?
it is running, so we're running. But then you could be suspended if it loses focus or the system goes into a low power state. And then if the system needs, obviously in doing that, it's taking a snapshot of your app's memory, your working set, so that it can very quickly and easily resume it when the user goes back to your app. But in stress situations, it can just kill it.
Yeah, because you're still really consuming resources at the point you're suspended, right? It just means you're just not the app that's active, I suppose.
Yeah, I mean, it's really just a memory snapshot, isn't it? So it's not a big deal. But there's yeah, that's right. But the systems depends on the system. Actually, a low-end Windows mobile device, 512 megs. That's not got a lot of space, it's got some memory that's running the operating system, it's got some memory for this and background tasks, and then there's a certain amount for keeping those snapshots, if you like, of these suspended apps. And there's going to be, you only need to get a few suspended apps and that cache is going to be exhausted. And then the OS is going to kind of look at the ones that are suspended and terminate one of them. Yeah. Less likely on a desktop, let's be clear about this. But you have to, obviously you're writing an app that can run on all of these, so you have to effectively expect the worst possible case. Yeah. Now in all of these cases, the system can be executing background tasks. That makes it look like background tasks are running continuously in the background, which probably gives a false impression. They tend to run in spurts, but and can be triggered by various
that actually say now.
There's various reasons that can cause a background task to execute, like a push notification coming in can cause it to trigger.
Or a timer or something.
Or a timer or time zone change or network. Anyway, lots of great reasons. Or Bluetooth in a device connected or losing. So there's loads of great interesting ways that stuff can happen in the background, but we're going to talk about that in another session. We're going to concentrate on this one down at the bottom, which is the foreground app experience and what you have to do as a developer to make things work. Now this way, that app lifecycle we just talked about, is the same on all Windows 10 UWP devices, so it's consistent. What will change, obviously, is the frequency of termination depending on the system resources. Some of the quotas change according to the device resources, but the actual behavior, the cycle, the life cycle is the same. So this again is another view of the application lifetime. You get launched and then you're running, you're using the full resources of the system, and then at some point the user chooses to watch to actually get a different app or something. At that point you're suspended, and on desktop you get 5 seconds to do suspension logic before you can't do anything else. So you might want to save data and make sure everything is sound at that point. You then are in suspended state. The system is retaining the snapshot of your app's memory and working set all ready to go again, and then at some point the user reactivates your app, goes back to it, and then immediately you're just slotted back into working mode again, reloads your app, and you set off just as if you've never been away.
So it is like a rehydration, really, of the data. Yeah. And in that suspension of the 5 seconds, what sort of things should people really be doing there? Like,
I've got a slide. I'll go into that in a bit more detail in a minute. Yeah. And then at some point down here, terminated. But the key thing there is no event. So you will not get an event fired once you're in a suspended state. So that the key takeaway from this is, if you imagine that you're going to be terminated, you can't leave your app state in a kind of in a disorganized thing. It means that when you are suspended, you need to make sure everything is locked down and sound, just in case you get terminated.
Well, it makes sense. You won't get an event because you would have been terminated, so you can't pick up the event.
Good thinking.
Law of causality. There we go.
So the key events in this that you can react to are launch, suspend, and resume. So here you go, launch. The user launches your app. You go from a not running state. Maybe the user chooses the app from the apps list, or maybe they tap on the tile if they've got it pinned to the start screen, that sort of thing. And they launch, and you now are into a running state, using for no particular reason the calculator as an example. So here we are, we're running our app and it's running and the user's interacting with it and life is good. Now, when that happens, you actually get this on-launched event, and we've already seen this. This is the key kind of logic. This is your bootstrap logic for your app.
Yeah.
And you get some interesting information. First of all, you get in the arguments, the launch activated event args, you get this parameter called previous execution state. So this is interesting. It allows you to find out, while you're at the point you're being launched, what was the state you were in previously, if this app, which may be not running at all, maybe it's just been installed for the first time. Maybe it was running, maybe you are running. So, you can actually there are cases where you can get this firing and you're already running, so you probably don't want to do very much in that case. Maybe you were suspended, maybe you were terminated, and maybe you were closed by user. We're going to look at each of these and see.
Okay.
But having that information is important for then knowing what you do next in your sort of startup logic. And you also find the activation kinds, another thing that gets passed through in these activated event args. So the way that what kind of a launch is this? So there are different ways. I mean, I talked there about starting from the apps list or from a tile. That's just
like
a
normal launch.
Yeah. But actually there's a whole bunch of ways that an app could be activated.
Cortana could be on the voice
commands. Cortana, voice command could launch it, yes. File and protocol, we've got these APIs which are kind of for app-to-app communication.
Talking about that later, right?
We are talking about that later on, yeah. But I mean, for example, a file, you could be, maybe your app is a PDF reader, for example. So you would register your app to be, I know how to handle PDFs, and
someone double clicks.
And someone double clicks on a file, in Windows Explorer, a PDF, and then if your app is the one that the user has selected as being the preferred app for PDF reading, then this would come in here and you'd launch your app.
Which would make sense. And at that point, you'd obviously know that it's a file, and then you check what file it was, and then you'd go and load that up. Yeah,
that's right. So. And there's various others as well. So, but the key one we're going to talk about here is launch. So now at this point, your app is minimized or moves off screen, which is a sort of way of saying is not being used anymore.
Not active.
Yeah, not active. Yes, or on desktop, maybe the minimized lock screen goes up. Maybe you're on low power mode, and the system itself is going into a low power mode. Then at that point, you're going to be, or maybe a phone case, maybe you get a phone call, so your app loses focus on a mobile device, or the user taps the start thing and goes and does something else. So app is suspended, all code stopped, no timers tick, no events fire, process is still alive, it is suspended and in memory. So we've got all these different things. It basically is in suspended state at this point. Now on desktop family, UWP apps suspend when they are minimized or when Windows enters a low power state. On mobile, when you've only got a single window, UWP apps suspend when they are basically no longer the foreground app. So maybe the lock screen comes up, or the user handles an incoming call, or they even start another app. So as soon as you're kind of no longer full screen, then you're suspended. So here we go, application.suspending event. In the file new project, you do get you basically get this code. This is the file new project version of on suspending, which doesn't do anything actually.
No.
But at least, because pretty much every app is going to need to do something, you're given this very empty on suspending event handler. So in here, this is where you've got this 5 seconds on desktop and up to 10 seconds on mobile. Although you are running at a kind of low priority in this case. Okay. But this is your last chance to save your application's data and stop anything, if you want to, stop any background activity. So basically do a clean kind of, okay, I'm suspending, let's just sort of stop. And in most cases, how much do you want to do really here?
Well, that's the thing, because I think as well with some of this data, you sort of do incremental sort of saves anyway. You don't wait for this moment before you think, oh, I better start saving stuff. You sort of, it's as and when you realize, okay, well now really is my last chance. Let me just make sure I've got everything.
Oh, it's totally right. I mean, like the to-do app, actually it saves data every time you've finished editing a to-do item and you've gone back to list, it will save the data
That's
then.
Really the best
which is the best model. So it means by this point you actually haven't got anything to do in terms of making sure the permanent data is kind of is sound. So, but this is your last chance to do anything that you need to do just to make sure that if you did get terminated, then there would be no unforeseen circumstances.
Yeah.
So that's that. You know, you have got limited time to run, so you need to do the minimum amount of work in here. Now the thing is, if you do call any async APIs, you do await anything, then you need to get a deferral. In fact, you know, we do it for you anyway, so don't delete it basically. So anything in there, if you're taking any awaitables, then this is the pattern. You get a deferral first, and then when you're finally finished and you've awaited everything, you'd have to put an async void on there. But then you call deferral.complete, and then we're all good.
Yeah, you're just letting us know, like, hey, it's done.
So at some point, the user goes back to your app. Maybe they actually have finished using the browser. They go back, or they hit a tile or something to go back into your app, or they press and hold on the phone anyway, or on the back button to get the apps task switcher up, or on desktop you can go into the what's it called, the the desktop thingy.
Alt tab or the Windows tab.
Yeah, that's right. So you can see the thumbnails of your apps, and you can just reactivate them. So at this point, you just get start up again. All your code runs, and your code has a chance to. You just pick up exactly where you left off, really. So in many apps, like a calculator, it's probably nothing to do. Well, it's not like you. It's nothing to do really. And this is like the the desktop thing. So similar kind of thing. You can just kind of say, okay, we're going to start using you again. So at this point, you get started. Now, there is a resuming event, which in the file new project templates isn't actually hooked.
Okay.
But you can obviously you could do it. You could add that yourself if you've got specific logic you need to do on resuming. And I think the next slide. Yeah, what to do on resuming?
I was going to say,
what do you do on resuming? Well, there's no one hard, fast rule for this. It depends on the app and what it does. But if your app uses data from an online source,
maybe get the latest version.
You probably want to refresh and get the latest.
Pick up the latest.
Maybe if your app does different things depending on whether it's online or offline.
Maybe geolocation.
Maybe you want to take a look and say, okay, have we changed status since when we were last running? And if so, you obviously need to flip over to offline mode or something.
Mm-hmm.
Yeah, then the sensors, you might need to sort of just refresh that and take a new view. And here's a weird one actually. If you've done an async networking call just before you were suspended, actually that will complete when you come back, but it will complete with an error. It will say call cancelled or something.
Yeah, you'll be able to check the state and it'll say.
That's right. So you might need to have to retry that.
Mm-hmm.
And maybe you've got background tasks associated with your app, and they might have gone off and got some data that's relevant as well. So these are things that you might have to think about, but for many apps there's nothing to do. So, but for some, you might want to think about these sort of things that you need to do. When
just anything external, just make sure you've got the latest and hydrated versions. Yep.
But the other thing is a bit more subtle. So you also want to think about how long have I been suspended?
Yeah.
And again, this is something that there's no hard and fast rule for every app. You can't say every app must do this, but you might want to think if you resume after a short period of time, then you want to put the user state, resume them back to where they were, which is the default state, because it will by default it's just suspended all the memory and everything for your app. So on resume, you'll just go back to exactly where you were. But actually, you might want to circumvent that. If you resumed after a long period of time, then you actually might want to put the user back to the default start
it's like
page,
a launch,
as if it's a new launch.
Yeah, which makes sense.
Because that might have been the user's expectation, really. I mean, it's kind of days since they've used this.
It depends on whether the user remembers where they were when they launched the app again. They'll be like, "Oh, why am I here?"
Exactly, and that's why there's no hard and fast rule. It depends on your app and what makes sense.
It's more the scenario, really, isn't it?
It's a scenario.
Yeah, it's a scenario-driven thing.
Yeah. You might even want to ask the user. It depends on the app again. You say, "Do you want to resume, writing this, or do you want to resume?" Especially with games, that's a great example.
Yeah.
Do you want to resume the game, or do you want to start over? So again, that might be appropriate just to ask the user at that point, and then do the right thing. So.
Yeah. Okay.
Right, now, if you want to test all this, how do we do it? So the good thing here is, or the not so good thing here is, the thing that trips everybody up is that actually, if you're running under the debugger, and then you minimize the app or whatever, and you're expecting it to suspend, and then you test your resuming logic.
Doesn't do that.
It doesn't do it.
Yeah.
Because when you're running under the debugger keeps it alive.
On. Yeah.
But obviously we've anticipated this, and there is this special toolbar called the Lifecycle events. Is that called the Debug Location toolbar? If you go to Show Toolbars, I think.
Oh, I don't know actually. I can't remember. It's
okay. It's got a name.
Once you do it, it's there, so you never worry about it.
That's right. For most of us, it's there all the time. But if you don't see this, you have to go into View Toolbars, and then it's got a specific name. It is the Debug Location because that's what it says on the slide. That's why I put it there. Okay. It's called the Debug Location toolbar. So if you're not seeing that while you're running, you won't see it when you're just coding. Then you need to go and enable that. And that gives you options to suspend, resume, and that one called suspend and shutdown actually means terminate, because a terminate by implication has to suspend first. So you have suspend.
You always get the suspend call,
yeah,
and then it sort of terminates. Shutdown is.
I don't know why they didn't call it suspend and terminate. But it's called suspend and shutdown, and it always has been, so there you go. So you can actually do this. The grayed out one, no background tasks. If your app has background tasks, you can also launch them for debugging from this toolbar, which is very handy, because otherwise, you don't have to wait for a timer to run or something. You could wait for ages for something, but that's another topic. So let's talk a little bit about termination. So we actually had a question from RC Roder. Thank you for your question. I gather tombstoning is now gone. So tombstoning was the term that kind of means termination.
It does sort of mean termination.
It sort of means the same
we just
thing.
Don't use it.
But we don't use it anymore. So tombstoning was the term we used for Windows Phone Silverlight apps. And I have talked a lot about tombstoning in my time. But no, with Windows Runtime apps, with UWP apps, we don't use the term anymore. Instead, we talk about termination. But it's essentially the same thing. It is the same thing. So what about termination? The OS can terminate your app. So here we are. You're running another app. The OS gets short of memory. It's going to be more likely to happen on low memory devices than on desktop machines, but could happen anywhere depending on circumstances. And the OS will choose one, not necessarily the oldest,
I think there's a whole load of heuristics that go in that it makes a decision. It's not as a. It's
not something you need to know about. You just have to know that it can happen.
You should have the assumption that you will get terminated.
Yeah. And it doesn't sort of it doesn't suspend. It doesn't kind of activate it for a few seconds and then send it a terminating event so you can do anything. No, it just blows it away. So you don't get any notification. It's just going to be removed from the task switcher list. It's gone. It's disappeared.
I would say once you've got the suspension event, you should treat yourself as in I'm going to terminate.
That's exactly the key thing. Yeah, that's exactly the key thing. So what happens when the user returns to a terminated app? Well, the user will be unaware that the app was terminated. Now, actually, the calculator is probably not a good example here because they tend to be very short user interactions. But think of an app that's got more of a workflow about it, this sort of thing. Here, at this point, they just want to start the app again. They don't need to know what's been going on and how the OS has been managing its resources in the meantime. The user just wants to run the app, and they probably want to get back to where they were.
Yes.
But again, that comes into this time dependency as to how long ago it was that they last ran it. It's all scenario driven. But let's assume that they want to go back to exactly where they were. So they often might expect that their experience simply just continues like where they left off. So this is where your job, Mr. Developer, is to help maintain that illusion and to put them back just where they were. And unfortunately, the system can't do everything because, again, this is scenario dependent as to what you should do. So you have to write some code to do this. So the idea here is the user mustn't lose data and should continue recent activity, underlined recent, because if it was so long ago they can't remember what they were doing, best to return them to the launch page. So as part of that, so if you remember when we suspended, we said that the key thing here is to make sure that the app's permanent data, its persistent data, is stored away. So whatever its storage medium is, whether that's in files or whether it's up on a cloud service or in a SQL-like database, whatever. It's got to be, you've got to be a sound, shut down, sort of consistent data storage from that point. But then, in terms of putting them back to where they were, now what we're talking about is something called transient session state, session state. This is kind of it relates to the user's particular session with your app. And the stuff that is included in that bucket is what pages have they navigated through. They might be on page 4 of a sequence of pages. You want to put them back on page 4. Cool. And when they go back, they want to go back to page 3 and go back to page 2. So that page history, this is where ties into the page navigation that we were talking about earlier. Stack. And actually, not only that, but obviously you need to restore, when you go back to that page 4, if it's sent a navigation parameter, that needs to go with it as well. Yeah. Now, fortunately, the frame class helps you with all of this, as I'll show you in a minute. But also, you might have the user was in the middle of doing something. They might be filling in some data, and they might have been halfway through writing a really long note to somebody. They haven't completed that task yet, so it's not been saved into the permanent state of the application, but nonetheless it's still something they're in the middle of, so you might want to restore the value of those fields as well again. And just to stress, every app defines recent differently, so there's no one hard and fast rule for this. You've got to do the right thing for your app, for your scenario. Right, that's a lot of talking. Let's finally demo it, yeah. All right, so here we go. This is the app from earlier, the lifecycle demo. I said we'd come back to this. Here we go, next page, page 2 and page 1, and life's good, main page, and here we go. And we can put some stuff in. And here's on page 2 now, we've got 2 fields. So here's some data and some more data. And so then when we navigate back, it's restored, because that is effectively a very simple example of the permanent data for our app. That is its sole purpose in life is to store 2 string values. It's a very exciting app. Yeah. Now, how does it do that? So actually what we've got here, we've got a view model, even got a little good architecture in here. And when we go into the page, we load the data from the view model. And we're actually pulling out of the roaming settings the values of this field 1 and field 2. So roaming settings is our data storage for this app. Got a key called the data, but essentially it's stored as there's JSON and we store it in roaming settings, which means roaming settings actually roams across all the user's devices. So this is a simple example of a permanent data store.
So it's like a cloud-based storage, really.
Cloud-based storage, yes, exactly. Yeah. And then when we go back from the page, we save the data. So this is where the user has finished entering stuff onto those fields, and it saves it. So that's kind of, that's all good. So, here's some data and some more. You can see the data's, even across runs of the app, that data is persisted and it's got out of our roaming settings. So that's great. All right. Now then, let's have a look at the app lifecycle. So we're going to put a breakpoint here on suspending. And there's a note there. You say you must ensure the app's permanent data is safely stored, but we don't need to do it in here because we've already done it on page navigation. Yeah. Now, we've just minimized the app and it hasn't suspended. That's because the debugger, Visual Studio Debugger, is getting in the way. So instead, if we want to suspend, we have to do that through there. And now we're hitting on suspending. We just keep that running. Got nothing to do in this particular simple example. Okay, that's nice. Right, let's resume it. Well, before we do, let's see where we've got. Oh yeah, here we go. We've got an on-resuming event, so we'll put a break on point on that. Now let's resume it, and not surprisingly, we hit that. So again, got nothing to do in this simple example, but we already talked about what you might need to do. All right, so that's all right. Now then, what about, let's go and terminate it. So we're going to do a suspend. So we go through on suspending, like I said, but then it's dead. Ignore the icon still appears on the taskbar at the moment, but it is actually. I suppose that's an indication that you're debugging, I guess. But now then, you get this code in the new project templates. In onLaunched, you can actually, you've even got, we've got a breakpoint on that. The previous execution state is terminated. So now we can actually do some logic in there to kind of restore from a terminated state. So there's nothing in there at the moment. We're going to do something about that in a minute. All right. So that's fine. Now then, let's next. So here we are. Oh, we're suspending again. Yeah, good. All right. Now the next thing I want to do is here we go. I've got a little snippet here. This is where we're going to start saving on suspending the volatile state. This is the frame get navigation state, a really helpful method that serializes the navigation history and the navigation parameters into a string for you that you can then just save into your storage, whatever. So this is where we're storing the volatile state, and obviously we can restore that. So this is taking care of the page history. So there we go. This is the return set. This is where we can start bringing back in our volatile state. We're going off into the local settings this time because this is only on this machine.
Yeah, I was going to say I noticed it's only on this.
Yeah, that's right.
Yep.
So now we can pull that out of our local settings and we can call frame.set navigation state. So we're immediately restoring into the frame where we came from. So this is the first bit of the volatile state, the most important thing. So first of all, we just launched, so we're not going to do any of that. There we go, next page, next page. Here we are on page 2. And now, if we go and suspend and shut down, we first of all go through on suspending. Then we're going to step through this and we're getting our navigation state and we're saving it away into our local settings. And now, so we are terminated now, and then we can run it again, restart it. And now we're going to drop into this bit of code. So it was terminated, so now we can restore that navigation history. Now we just let it run. And of course we're back on page 2. So that's really cool. Straight back into the page where we were. So that's the kind of way that you would restore the thing. Now there's a more subtlety thing here. So here we are. I'm going to start writing an essay in field 2.
Okay.
So we go la 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 la. Permanent gets permanent data gets saved. That's great when we leave, but we're actually not going. So when we leave, it does save it. So that's all good when we leave this page. And now I'm going to write even more of an essay. So remember that saving the permanent data is tied to that navigation out of this page. But what if we get suspended halfway through entering some long text, blah, 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 you get the idea.
Yep.
And we don't navigate away from the page. So if we suspend on a termination, we're not actually going to navigate out of this. So we can show this.
So this will be interesting now.
Yeah, that's right. Suspend and shut down. So we go through on suspending. We save the navigation state, so that's good. Now you resume, and of course we will go back to. We'll get the navigation history, fine. So we'll end up back on page 2. But that stuff.
Your data's gone.
It's gone.
Yeah.
Data's gone. Unhappy user. So yeah, this is obviously bad news. But of course, the next little bit about the volatile state is to fix that. So that's all part of what we call the session state, the volatile session state, like we say. So let's just recap then. Given now what we know, what actually do we have to do on suspending? So yeah, sure, we need to make sure it's your last chance to say that the app's permanent data is sound, is secure. But of course we do know now that you may be terminated while suspended. And you don't get a notification, so that's, again, drilling home why you have to make sure that the permanent data is solid. But in addition to that, we need to save our session state sufficient to return a user to where they were if they return to your app after termination. Qualified by saying how long it is and you might want to throw it away and all this kind of thing. But
in general. Asterisks.
Yeah, that's right, yes. In most cases, yeah. So yeah, you can kind of get the frame navigation state serialized as a string. So that's all good, so that's all good. So on suspending, you might want to also save the volatile state of a page. Yep. This is the situation we just showed you, where the user's halfway through doing something, and we want to save the work in progress as well as the permanent data in case we want to restore that and put them back exactly where they were. And that's of course time dependent and loads of other things.
Makes sense.
So essentially on navigated from, because even when you here's the thing. So my sample was carefully arranged so that on a back command we saved the permanent data.
Yeah.
But actually, simply on navigating from the page, we don't save the data.
Okay.
So on navigating from happens, you navigate from a page even when we're on suspend.
Yeah.
So on suspend, we do want to make sure that we can save the. We probably want to save the the volatile state of the page.
Okay.
And then, of course, when we come back in, you might want to restore that. So in on Navigator 2, yeah, if we want to, you go and find out if there is in the state dictionary these values, and then you pull them out and use them to use them to rehydrate your state on the page. But then you want to clear them out of the state so that it's not hanging around. So
yeah, because you don't want it to go stale after you've rehydrated. Exactly. Yeah.
So that's essentially the pattern. So to add that to this sample is pretty straightforward. So here we are back where we were in this thing, and now we're going to go and add a little bit of logic to our sample to save the state. So on navigated from, here we go. We are got a little sample here. Save the volatile state. So all we're doing, I'm creating an application data composite value, which is this a composite of values, as the name suggests, and we're going to store that into our local settings. So this is on navigated from. Now, actually, really, this should be done in your view model. It's not. It offends me. It offends me this a little bit.
But anyway, demonstration purposes.
For simplicity, that's why I'm doing it like this. Now, here's the thing: a subtlety. If it's a new navigation, remove it from the state, because a new navigation is a proper forwards navigation into the page.
Okay. Yeah.
But if it's not a new navigation, it's actually a back navigation. Then we could be coming back from a terminated state. So let's set a breakpoint on there, and we'll set a breakpoint on there, so we can just track through what's going on here. All right, so here we go. Let's just try this out. Here we are. We're back into a new launch. I'm not bothered about that anymore because we've done all that. That's the page history stuff. We know that works. So next, here we are. Now we're going in on Navigator 2. Are we in a new navigation mode? Yes, we are. So just remove it from the settings. It may be not there anyway. It won't be there. So we're now in a clean. There's nothing in our local settings cache. Now then we start entering like we did before. We actually are. This is now becoming a new work in progress. Put this in. And now I'm going to go back and terminate my app again. Here we go. We're on suspending. Now here we are on navigated from. So this is where we're saving that work in progress. We're storing it in our local settings. Yeah. And so now we are terminated. So now we can start it again.
It's application data composite value is the key.
Well, yes, that's just a nicety. It's not crucial to this. Now the navigation mode is back, so it's a different navigation mode. So here we're going to pull those values out of our local settings and use it to rehydrate the fields on the page and back on the page, and yeah, it works.
Perfect.
We're back exactly where we left them. So that's kind of the story, really. Yeah, it's a new navigation. So you can see that it all just works out nicely. Yeah, and we've got all that data saved. So we're cool. We're in good shape. Yeah, so that's the key elements of handling the lifecycle. Mm-hmm. Now, certain frameworks such as Template 10, aka.ms/Template 10, has a more kind of sophisticated way of handling saving state. It gives you nice state dictionaries, and you actually get on navigated to and on navigated from methods in your view models, which is kind of makes sense for your page view models, rather than having it in the page. But I wanted to keep it simple so you understood everybody understood the things. Now, so what help do we get from the framework and the templates? Well, as we've seen, the frame class has get set navigation state.
Yep.
That's it. That's the help you get. So
it's not much.
No. So those of you who have been Windows 8.1 app developers will know that if you certain project templates there plugged in these classes called the suspension manager and the navigation helper.
Yeah.
Which helped you with all of this kind of stuff as well. It's another framework. It's fair to say not everybody liked them, but they were provided out of the box. You could, in theory, I suppose, support those if you like. So UWP project templates not include any of these. So you could take the old 8.1 versions and try and figure out how to get it to work. Maybe I should do that. I haven't done that yet.
Yep.
Or write your own framework, or use other frameworks such as the template
10 stuff.
Is one example. I'm sure others will arrive, in course as well. So that's it. That's the story for that. Now the other one I haven't really talked about is close by user. So close by user, just so that you're aware of this as kind of completing the story. If the user closes an app using the task switcher on mobile, or hits the X on the title bar on desktop, or Alt F4, or the close touch gesture. Does anybody know that? Swipe down and hold until it rotates. Yeah, all of those actually do close an app. So the other way is, they just sort of end up suspended or eventually terminated. So. So the back button does not close the app. So if you navigate away from the app, it's still kind of sitting there, it's still suspended. But again, this is the only reason for highlighting this. So this is a normal, when the user closes it, this is actually causes the app suspends, and then actually it terminates. So this is kind of a subtle side case, if you like, of what we just showed you about recovering from termination. So if you look at the reason for termination, you look at the last execution state, you can actually see there is a closed by user status. If that happens, you probably don't want to put the user back to where they were.
No, I think at that point
if they specifically closed it, then they are expecting it to be closed. So
it's like a fresh launch.
It's a fresh launch, exactly. So, and that's it. Now, there are other forms of activation. We touched on this at the beginning of this session, and I'm not going to go into we are talking a bit tomorrow about toasts and tiles and Cortana. There's others, and URI associated file. All of these kind of things are all ways that your app could be launched, and there are specific patterns. There's an on-activated event in your app.xaml.cs which will get fired for those kind of situations. Now, again, you need to look at each scenario. Generally, if you're supporting these kind of activations, you've designed them in. They're not kind of things that happen by accident.
Yes.
So when you are launched from one of these things, as the app designer, you have presumably got a specific scenario in mind. So it depends on the reason, the way of being activated, but you may want to resume the previous state the user was in. You might want to put them back on their page, but you more usually, if you said Cortana, you said
something quite specific.
Yeah, like create a new item. Yeah. You want to put them on the new item.
The user's already pretty much told you where they want to go in this instance. Yeah.
So you just need to handle this the right way. So and do the right thing with the app lifecycle. There's an interesting side case though. So if, say, for example, you get a search contract activation.
Yep.
So you've set your app up as being something that people share contract. Something that people can share things with. So when they share from one app, your app comes up as one of the targets. And if they choose your app, then your app gets activated, and you kind of run this little transient UI to handle that. And you can so then you need to handle that, which usually you'll have a specific page for that experience. You maybe do that specific interaction with the user, and then you're going to close again,
off.
And you kind of return, and then it returns back to the caller. So obviously in that circumstance, you don't want to touch any stored session state, because that's a very specific kind of transient extra state of your app. So there's different scenarios for this, and I'm not going to go into much more about this there. So they're usually specific, unique user experiences. Right, lastly, the extended execution. So requesting extended execution. So this is brand new for desktop. We kind of had scenarios of this turn-by-turn location tracking, last seen in Silverlight Windows Phone 8.0.
Yeah.
Well, you can do it now. It's back and it's in UWP. But there's other specific things about asking for extended execution. So there are two scenarios. I have a special need for extra time on suspend for some reason. I've got loads of data to save or something complicated. Or the other scenario is I'm actually a special kind of app. So let's just look at those. So here we go. The first one is essentially when you're on suspended, you can say at that point, hey OS, I need more time. And you then get this short period where you can actually do more execution, but you can't show any UI, but you get given more time. If you take too long, then the system will give you a revoked event, and you basically that's your 1 second warning, and you've got no more time.
But the extension doesn't have a predefined time, right?
I don't remember.
Your revoked has 1 second.
Yeah, the revoked has 1 second.
But you don't know.
Yeah, no, you don't have a specific.
There's no specific, so you don't know. Like I've got 6 seconds from the request being accepted.
No, that's right. So this is how you request an extension.
Yeah.
So maybe you need to upload some data. You will hook a session revoked event in there, but what you do is you new up an extended execution session, and you have to give a reason. Extended execution reason dot saving data, which I think is the only one that's valid at the moment. But clearly, this has been designed for future expansion. Yeah. So on revoked, you just say, well, this is not a good example really, because say saving complete. You probably actually want to set a flag so that next time you run, you try and recover the situation somehow. But first of all, you have to you create the session, but then the key thing here is the request extension async.
Yeah, so it's never guaranteed, basically, what you're saying here.
If the
OS could just go, you know what, I need this more than you do.
Yeah, if the OS is under stress, it's saying, oh, sorry, no way. So then you might do a basic suspend, which would be your normal suspend, upload basic data. Otherwise, you've been given some more time, then, well, we'll do a full suspend, a full save, and that sort of thing. And then you have more time to do this clean shutdown.
So really, you should never should really rely on this every time. It's just nice to have if you've got the time.
Yeah, so there's the start of it, and there's the basic logic of this thing. Now the other one, case 2, is the idea of something that running for a long period in the background. So this is a foreground app running in the background, which is something that's always been. It's very difficult for people who design mobile app
foreground app that runs in the background.
Yeah, we don't like that sort of thing. This is otherwise known as a battery burner, but there are obviously very good examples of systems where you want to do this. Typical one being a sort of satellite navigation kind of a turn-by-turn navigation system.
Yeah.
Where you want the app keeping on running in the background, but it doesn't actually need. It doesn't need to be showing any UI at this point, but it's still tracking. It might be giving voice commands or something. But so here you ask for it, and you just keep on long running in the background. You might be revoked, and again, you kind of given a 1 second warning.
1 second.
Yeah, not long. So the way you do this, here we are, the requesting extension in the app. There's only one that's allowed at the moment, which is called location tracking, but again, this has been designed for future. And then you check, and if you're allowed, then you carry on and off you go, and otherwise you say, well, no, I can't do that. So there you are, you check again, request the extension, and away you go, running in the background. These are the different ways of extended execution reason. At the moment, as we said, there's only location tracking and saving data.
Yep.
And the result that can come back to you is allowed or denied.
Yep.
Yeah.
Makes sense.
That's quite clear, isn't it, really? And that's it.
Oh, wow.
That's it on App Lifecycle. Cool. So that was quite a long run through. It's a complicated topic, and not everybody gets it right, to be frank. So, that's it. Application Lifecycle, handling suspension and termination, and then we looked at obviously permanent state and session state and a pattern for kind of handling that, and then finally we looked at extended execution.
Yeah.
Okay, we're done with that. Thanks very much for watching that one. We're going to take a 10-minute break, and then we're going to come back. We're looking at XAML perf and then XAML tooling. It's all we're talking about perf for the next hour really in a couple of sessions.
Pretty much.
Yeah. All right, see you soon.
All right, thanks.